In this video, we're going to talk about using our knowledge of parallelograms in order to write some proofs about them. So up at the top of the page in the box, you'll see some of the facts, or all of the facts, that we learned in the last lesson regarding parallelograms. If you haven't yet viewed the video on the last lesson about properties with parallelograms, you should go back and watch that prior to writing these proofs. Once we know something is a property of a parallelogram, then anytime we want to write a proof about a parallelogram, we can actually use that property in our proof. And that's where we're going to go with these today. So I'm going to go ahead and jump right into the very first example. It tells me in the first given that JKLM is a parallelogram. Once I know that something is a parallelogram, I know so much information about it that it's going to be impossible to mark everything in the picture. So a lot of times what I'll do is I'll just take a highlighter, and once I know something's a parallelogram, I'll highlight it in my picture, and that'll be an indication to me that the figure that I'm working with is indeed a parallelogram. So I'm just going to take my highlighter and highlight parallelogram JKLM. I also know, due to the givens, that segment JO is congruent to segment OL. So I'll mark those in my picture as well. And what they're asking us to do, or what they want us to do in the picture, is they want us to prove that segment OP, so OP is that green segment right there, is congruent to segment OQ, that green segment right there. So as soon as I see congruent segments, I think to myself, if I could just prove that triangles that contain these segments as sides are congruent, I can use CPCTC in order to prove the segments themselves are congruent. So my goal or my mission now is to get those green triangles congruent to one another. Well, the given segments JO and OL represent one pair of sides. I could use the vertical angles at O to get a pair of congruent angles. And because my yellow figure is a parallelogram, I know that the top side of the figure has to be parallel to the bottom side, giving me some pairs of congruent alternate interior angles. So in other words, angles 1 and 2 are congruent, as are the alternate interior angles at point P and at point Q. So I actually have a couple different ways. I could prove these triangles are congruent by angle, angle, side. I could also prove the triangles congruent by angle, side, angle if I use the vertical angles at O. So the choice is really up to you. I'm going to do angle, angle, side using the two pairs of congruent alternate interior angles because it's going to end up being a slightly shorter, more efficient proof. But again, if you were desiring to use the vertical angles at O, that would be okay as well. So one pair of angles I want to talk about in my proof are angles 1 and 2. I'm going to call the other pair of alternate interior angles 3 and 4. And then lastly, my pair of congruent sides, JO and OL. So I want to talk first about angle 1 being congruent to angle 2. I knew they were congruent because of the parallel lines, and I knew the parallel or the lines were parallel due to the fact that JKLM is a parallelogram. So that's really where I need to begin my proof. JKLM is a parallelogram. I know this is a true statement because it's given to me to be a true statement. And once he's a parallelogram, again, I know a lot of different information about him, but the piece that's important for me in this proof is to show the top side is parallel to the bottom side. So in other words, side JK is parallel to side ML. And that's because in a parallelogram, opposite sides are parallel. And then once those opposite sides were parallel, then I can go ahead and conclude that angle 1 is congruent to angle 2. That's one pair of congruent alternate interior angles that are congruent due to the fact that the lines are parallel. Angles 3 and 4 would be another pair of alternate interior angles that are congruent due to the parallel lines. So I'm going to go ahead and put those right in the same spot. So parallel lines, remember your discussion of parallel lines here because the lines have to be parallel in order for the alternate interior angles to be congruent. So I've now talked about my first pair of angles, my second pair of angles. I'm now going to discuss my pair of congruent sides. So OP is congruent to OQ. And that's due to the fact that they're given to be congruent. I'm now set up to go ahead and say these triangles are congruent. And remember, when you name your congruent triangles, make sure you match up your corresponding parts. So in the first triangle, vertex J corresponds to vertex L in the second triangle. O corresponds to itself. P matches up with Q. So that order of the second triangle there is very important. And then once the triangles are congruent, I know all of their corresponding parts have to be congruent. And OP and OQ are a pair of corresponding sides in the triangles that I already proved congruent. And one thing that you might have caught as I wrote my proof that I didn't catch until right now is I've got to go back and fix this given. OP and OQ were not what was given to me, or not my congruent sides. The sides that were given to me that I needed to write about in this proof that were congruent were JO and OL. So I'm going to make that one fix. Now I feel pretty good about that proof. Okay, if you have questions, I would write them in the margin right now so that you can remember to ask me about them the next time that you come back to class. In the meantime, I'm going to move on to this next proof. And I do need to let you know that in the next proof there is a typo. The first given, ABCD, is a parallelogram. That's all good. And like I did with the first one, I'm going to go ahead and highlight ABCD just as a reminder to myself that it is a parallelogram with all the properties of parallelograms. The second given is where the typo occurs. It should say D is the midpoint of segment AE. You want to go ahead and make that fix on your paper right now. And the triangles that we're trying to prove congruent here are triangles DCE and CDB. So the red ones. Well, I know because the yellow figure is a parallelogram that it has all the properties of parallelograms. The opposite sides are congruent to each other, and the opposite sides are parallel to each other. I know that the opposite angles are congruent. I know that the diagonal splits it into two congruent triangles, but for now, the only thing I'm going to mark are the opposite sides that are parallel and congruent. Because D is the midpoint of segment AE, I know that AD and DE must be congruent. That's useful and helpful because now it gives me one pair of congruent sides. The shared pair of sides up the middle, reflexive property, will give me a second pair of congruent sides. And then lastly, the fact that the left side and the right side are parallel makes these angles at D and C, I'm going to call them 1 and 2, alternate interior angles. And anytime we have alternate interior angles on congruent line or parallel lines, we know that they have to be congruent. So my mission or my goal is to prove these two triangles congruent by side angle side. And again, I'm going to do this by talking about side DE being congruent to side BC, by angle 1 being congruent to angle 2, and by side CD being congruent to itself. So the first thing I want to discuss in my proof is these congruent sides DE and BC. It's not part of the given. I used the parallelogram in the midpoint to get those, so that's where I need to start my proof. So ABCD is a parallelogram. And because it's a parallelogram, I actually know a couple different facts. The first fact I know is that the opposite sides, AD and I'm actually going to call them AE and BC, are parallel to each other. And that's because parallelogram has opposite sides that are parallel. And I'm going to leave that for a minute because I really wanted to focus in or narrow in on showing why these sides DE and BC have to be congruent. I do know that side AD has to be congruent to side BC because in a parallelogram, opposite sides are congruent. And the other piece of information that told me that those pieces were congruent to each other was that second given, the fact that D is the midpoint of segment AE. And remember, the midpoint divides a segment into two congruent parts. So that told me that AD and DE were congruent. And now a little bit of substitution here. Both of these are congruent to AD. So I know that DE has to be congruent to BC. And that's substitution. I know that angle 1 is congruent to angle 2 due to the fact that I have these opposite sides that are parallel. And anytime I have parallel lines, the alternate interior angles are congruent to each other. And then the last pair of congruent parts I need you to talk about before I can make these triangles congruent is side CD being congruent to itself. And we know that's a true statement because of the reflexive property. So at this point, I've discussed everything I needed to discuss in order to make these triangles congruent to each other. I can lastly go ahead and say that they're congruent by side angle side. All right, like the first proof, if you have any questions, I would ask you to write them in the margin right now so that you can remember to ask me that the next time that you come back to class. The other thing I'd like to do is go ahead and fill in the key ideas and important understandings up at the top of the next page and see if you can use your newfound knowledge to complete number 2 on the next page.